Hey, Sam, thanks for coming on the podcast. Really excited to have you on. I'd love if you could share a bit more about your background for those that don't know about your background, a bit about how you came to founding Mysten Labs and creating Move as well. And then we'll love to dive into each of those topics in further depth later.
Hey, Sean, thanks so much for having me. I'm really excited to be here. So, yeah, let me talk about my background a bit. I started off my career as a programming languages researcher. I did a PhD where I spent a lot of time building static analysis tools, studying programming patterns, trying to understand how programmers created bugs, and then building automated tools that could catch those bugs really efficiently and with a high level of precision. And at the time I started off doing this work, it was basically leading toward a career in academia. It was like fun esoteric math with some components of tool building. But I'd spend a lot of time building these tools. I'd run on open source code, and I'd beg some developers to fix bugs. Sometimes they would, usually they wouldn't. And this was a lot of fun and considered a success. But the toward the end of my PhD, I did an internship at Facebook, and this was back when they were making the transition from web to mobile, and we were discovering like, oh man, it's way worse to ship bugs into mobile apps because you don't have control over the release cycle, so you have to take a lot more steps to keep them out in the first place. And so they were investing in all sorts of things to try to mitigate this problem, and one of them was this research grade static analysis technology. So I landed there, and it was a team that was just starting to turn this on for their Android code, and I was totally hooked by this. It was the same kind of work I did on my PhD, but instead of begging tens of developers to fix things, you ship your work in front of thousands of Facebook developers. You get real-time feedback. It's awesome that you found this. Hey, could you also find that? Like, this sucks about the tool. Can you improve it? And so I was like, great. Like, this is exactly what I want to do. Like, work at the intersection of research and production. So I joined Facebook after I finished my PhD, and I spent a number of years working on this infer static analyzer tool and looking at all sorts of interesting bugs. We started off with the sort of mundane stuff like null dereferences and buffer overflows, and then we get into some really interesting territories like looking at data races and trying to use static analyzers to help improve code efficiency and ship things that wouldn't be safe, in addition to just finding bugs. Then also went deep into C++ security. And I love this work a lot, but if you spend too much time working on static analysis, you start to develop a lot of opinions about language design. You see how languages set programmers up for failure by sort of having these things that are just too hard for fallible humans to do without errors consistently. And you also think a lot about how does language design make life difficult for tool builders like me and my team. Like, what could you do differently in the language design just to make things a lot simpler on both things, and to especially to make code compose well, so that when two pieces of code that never anticipated the existence of the other get smashed together, they still behave predictably and in a nice way. And so I got a chance to put these ideas to work when I joined the Libra project in 2018. This was a very small team, a secret project at Facebook with this bold mission of building a global scale payments network based on blockchain. And so they were just pulling in folks across the company with all the relevant kinds of expertise: databases, distributed systems, cryptography, payments, and then also languages. So they asked me to join and like figure out what we should do in terms of smart contracts. And as part of that, and I can talk more about this later, like this is what led the effort to create the Move language, and then also where I started meeting a lot of folks who are experts in these other areas and falling a bit down the Web3 rabbit hole as I studied what was going on elsewhere in Ethereum and Bitcoin, and Solana were the big platforms at that time. And so over the years, like, we built a lot of really cool things as part of Libra, and I like worked a lot on Move, but also got into protocol design and like really getting into how that intersected with cryptography and economics and the other interesting areas of this space. And this is how I ended up meeting the co-founders of Mysten. So Evan ran the research team at Novi and was my manager, and managed many other co-founders for several years, and just had a lot of vision for what you could do with this technology, and like was great at building a killer team that had all the relevant expertise. My co-founder George is a world expert in distributed systems. He spent a bit, like, he's been working on cryptography and systems since the 2000s, and has built several blockchains and knew how to blockchain startup before, and really has like great ideas on anything related to systems and how to make things fast and make them safe. My co-founder Kostas is a cryptographer who, he'll break anything. You're afraid to show him anything because he'll figure out how to break it. He's just like so creative and thinking about attacks and safety, and then thinking about creative uses for cryptography and for things like Move and things like DM. And then you have Adani, who's my final co-founder, who is a product manager, work with us, who seasoned startup guy and product guy, just has a ton of ideas on how to use this tech in creative ways and how to expand the reach of it. And so, we worked together and had a really great rapport and became friends as part of this. And we were always talking about like, at some point we should really like jump out of here and do a startup and try to do like the next thing beyond Libra. But we also felt a lot of conviction in the mission, and so wanted to like see the thing through to the end. And so basically around the end of 2021, it was becoming very clear that Libra was never going to launch. And so at that point, we're like, okay, it's time to give this thing a go. Like, let's jump out and start Mysten. Let's take the tech ideas that we were never able to put into Libra because it had a very specific niche of payments related needs that it was trying to fill. And like, let's try to build this L1 that's really works for the masses, that scales, that integrates Move in like the richest and most the powerful way that it could. And so that was the origin of Mysten. And then of course we spent the last 8 to 10 months just building Sui, building out a really killer team of engineers, product folks, ecosystem development folks, and just really trying to make a go of it with Sui.
Definitely seems like you were able to assemble a dream team from the ranks of the Libra team. Overall, I was curious about your experience specifically trying to build crypto and blockchain technologies within the four walls of a large tech organization. What were some of the benefits of doing so? Maybe from a talent perspective is what I'm hearing, but to what were some of the things that were holding you back as well, and that really led to you jumping in 2021 to create Mysten and form a new group focused on moving this mission forward?
Yeah, it was an overwhelmingly positive experience. As you said, the talent and the team was the biggest benefit. Like Facebook really invested big in this thing, and the quality of folks on that team, and like the diversity of their intellectual expertise, and also like their kindness and generosity with their time, and just like their curiosity to learn about other areas was unparalleled. I mean, I think there's at least 4 startups that have come out of that team. I mean, you have us, you have Aptos, you have Linera. There's also this Lightspark thing, and then a lot of other folks who've gone on to prominent positions at other blockchain companies like Chainlink or whatever else. So like the quality of folks on that team and like the number of good ideas they had collectively was just stunning. And the other thing about Facebook is they invested big in the team, but they also gave us the chance to do things that take a long time to build that just wouldn't make sense to do if you're a startup. Like I don't think you would be able to build Move at a crypto startup no matter how well funded you are. It takes years to build a language, to build a community around it, to get the tooling, to finalize design and get the ideas. And so got to give Facebook a lot of credit for having the willingness to pay that cost and to make those long-term investments. I think the main thing was holding us back wasn't anything about Facebook, but just like what we were trying to build, which started off with this vision of like, it's an L1 that can do anything, and then the regulatory pressure and sort of the time pressure led us to really water down the vision into this is basically a settlement layer between a bunch of different, hundreds of VASPs, and it does payments and it does compliance stuff, but it doesn't really do anything else. And so we just had to make a lot of pragmatic compromises in the design and in the vision to cater to what we were trying to build. Whereas like as engineers and as researchers, what we really wanted to build is like the thing that can do everything and really scale to arbitrary traffic instead of a payment-based settlement layer. So that was really the only thing, but that was the right thing for Facebook to be doing given the pressure that were coming from the outside and the product that they were trying to launch.
Got it. I wanted to also better understand some of the philosophy and design behind Move. I understand that, at least compared to Solidity, there's a lot more security benefits from a smart contract perspective. And I know there's been a ton of hacks and security incidents across different languages, not just Solidity, that have made the news, and not all of them are related to smart contract issues. Some of them are social engineering and the like. But I'm curious, what are some of the key benefits of Move? How did you think about designing it, and what are some of the advantages for developers in using this, and ultimately users of blockchains that are built on Move?
Yeah, absolutely. Let me back into this question by talking a little bit about the creation story, and I think answering that question telling that story will get into the answer to this question. Where when I joined Libra and was asked to look after smart contracts, the mandate wasn't go create a new language. Like that would be silly. Creating a new language is dangerous. It's scary. It takes a long time. It's like a huge investment. It's like basically the mandate was like figure out what are these smart contract things, like what should we do with them, like what are the different options. So we basically looked at everything at that point. We studied Solidity and the EVM, and we tried to understand. And we looked at a lot of smart contract code and tried to understand what are developers trying to do, what works well there, what doesn't. And so we looked at both writing a better source language for the EVM. We looked at adding tools to augment Solidity. We looked at using different virtual machines from the the Web 2 world, LLVM, we looked at the JVM, the CLR, WASM, all that stuff, and sort of retrofitting them to be more blockchain and suitable for smart contracts. And basically what we ended up concluding is smart contracts are really, really different from other kinds of code that people write. It's a lot more limited in so many ways. Basically, like you have, at the end of the day, you have a bunch of assets. Like the code is going to basically check that someone has permission to touch these assets, and then they're going to read and write and update and transfer them. And that's basically all. Like you're not going to use smart contract languages to write an operating system or a network stack or anything like that. It's a very domain specific task. And then there are things that you need in a smart contract language that you really don't need in a conventional language. In particular, like this notion of an asset that doesn't really appear elsewhere. It's silly, right? Because in the computer, it's all just bytes. There's no notion of scarcity. You can just copy things around freely, and other languages let you do that, as they should, because that's what they're for. But in smart contracts, you really need this feature. And what we saw, especially when we looked at Solidity and the EVM, is that this isn't present. You read the code, and this is all about assets, yet there's no type or value that represents an asset. Like you have these maps, and you sort of like encode things very indirectly in the maps, and you do transfers by, twiddling entries in the map instead of saying, here's the object, do you want it here? I'm going to pass it to you, now you have it. And so with Move, what we were doing is saying, let's try to find the right abstractions for programming with assets. Let's provide a type and value representation of assets, and then let's give that to programmers. And then let's bake in safety around that representation so folks can create their own assets that can't be copied by construction, that can't be created from thin air, that have ownership transfers so that when you pass them between procedures or put them into a data structure, you know exactly where they are. And then the other thing is, right, we were looking at all these hacks for like almost all of these come from dynamic behavior, things like reentrancy, things like dynamic dispatch. These make a lot of sense if you're trying to provide a programming environment where people can inject code, but in a security critical setting, letting an attacker inject code is the last thing you want to do. So basically, we're like, how can we get as much expressivity as possible while having fully static code? When you look at a function, a tool or a human can tell exactly what's going to be called, and no one can come along later and inject some code that changes the behavior in a way that you don't expect. And then when you have that property, it sort of gets back to what I used to do at Facebook. Like it's very easy to statically analyze your code, to formally verify it, and have really advanced tooling that goes beyond testing and checking that your code can be safe. And so that was the vision for Move. And then along the way, the one other thing that we discovered and really aimed for is that every new blockchain is coming out, and they're all just making up their own language. Like the situation is basically one language per platform. And this is just not a good way to build a large and cohesive developer community. Like you want folks to be able to port their skills and develop for multiple blockchains. You want it to be worthwhile to have investments in the tooling, in the tool chain for the language. And you just can't have that with the EVM or with these other blockchain languages. They overfit to so many design decisions of Ethereum that if you're going to use the EVM, your blockchain is going to look like a lot like Ethereum, and it's going to inherit a lot of the limitations. And then the other thing is, because of the security properties, it's because of the security issues, it's just hard to become an EVM developer. Like there's all these memes in the community of the EVM network effects are overwhelming and they can never be overcome. But when you look at the numbers, there's 5,000 developers that are monthly active EVM developers. And this is a tiny, tiny developer community compared to JavaScript, where there's like 16 million, or iOS, where there's 12 million. So with Move, we really want it to be a cross-platform language where you can use it in one blockchain, then you can use it in a blockchain that makes substantially different design decisions in terms of how it sets up transactions, how it sets up the database and the execution layer. And then it's worthwhile for folks to invest in the tooling, use the same language across all those platforms, use the same libraries in many cases, but still be a Move developer. So we really want Move to be the JavaScript of Web3 in terms of ubiquity, and that when you write code for assets, when you write code that runs on blockchains, it should be using Move. And we want to give platform developers the freedom to try out new ideas and things that scale better, that are safer, but while still having the same developer experience. So I think there's a long-winded answer to the question. Basically, like that's where we started off with, and then there's some other things we've discovered and aimed toward on the way.
Well, just one quick clarification question. Would this eventually be able to be used with Ethereum and EVM compatible blockchains as well? Or you're saying it's agnostic to any type of blockchain, or is it primarily non-EVM chains that this would work with, that Move would work with?
So it's agnostic. I think you get the most benefits from it when you're designing a new chain and you know you're going to use Move, and so you can leverage the properties of Move for faster execution, and like we do in Sui, and I'll talk about later, to like have faster consensus in some cases. You can also use an EVM chains, like we're working with Celo to integrate Move alongside the EVM in their platform. And you could also imagine like an ETH2 execution layer that runs on top of Move, or a Celestia rollup that's Move powered. So all these things are possible, and I hope those will happen too. But if you have Move in a different language running the same platform, you lose some of the safety benefits of Move, and that you have your nice Move types that have safety guarantees inside the Move world, but when they flow into the EVM world, those things go out the window, or you have to design some sort of interop that maintains them. So really, we think it works the best when it's all Move, but I think you'll see Move in lots of different places, even when there are already other languages on the platform.
I definitely see a lot of positive developer sentiment around Move, especially recently, including the Solana developer ecosystem particularly seems to be interested in learning Move. It seems like many influential developers are starting to move on there. I think you even have a lot of the Solana ecosystem starting to move in. Forgive the the reference, but moving into the Move ecosystem. I think Solana's former head of marketing became Aptos's ecosystem head. Where do you think the Move developers are going to come from initially and then over time? And what types of tooling and other types of support that currently exists for other smart contract languages like Solidity and the like do you think need to be built out to really enable Move to grow to the scale you envision?
Yeah, those are a great set of questions. Let me tackle each of them in turn. So I think the Solana developers being some of the early adopters and Move being so interesting, I think I see a lot of factors that could contribute to that. So one is they've seen the potential of a high throughput chain and really low transaction fees and what that enables you to build versus something where everything is going to be dollars or double-digit dollars, even hundreds of dollars to run. And so almost all the Move chains coming out are targeting really high throughput and low latency. So the Solana folks are already addicted to that kind of speed and what it enables, as they should be. And then they're like, well, if there's the potential to add a layer of better developer experience on top of that, then I'm in. The other thing too is, of course, like Solana is like, it has Anchor, it has the Rust SDK they use to write smart contracts, and of course it's implemented in Rust. Like there's a lot of intersectionality between the Solana community and the Rust community. So I think, of course, Move is strongly inspired by Rust in many ways. We try to make the syntax similar where it makes sense so that it's easy for a Rust developer to come and jump in. The Move borrow checker is similar to the Rust borrow checker in a number of ways. So I think that familiarity too is something that brings the Solana developers over and makes them happy to try out Move. So moving on to your question of like, where do Move developers come from in the short term and the long term? I think in the short term, they're going to come from technology curious existing smart contract developers like these Solana folks, like other folks from the EVM community or like other smart contract communities, where like, I always look at the emerging technologies because that's how blockchain folks are. If something looks like it has a lot of potential, I'm going to try it out and maybe even adopt it. I think like folks who are excited about a better developer experience, a safer developer experience from the existing smart contract dev community will be the earliest adopters. But as I was alluding to earlier, like there's not so many of these folks. You know, the 5,000 for the EVM, I'm not sure how many Solana developers are, but I think it's substantially smaller. So we're gonna have to find a way to pull in. Our biggest mission here is to broaden the pie of folks who have never touched smart contracts or crypto before, and to make that an accessible experience for them. And so in Sui, for example, what we really want is, if you're a product builder, if you're building a game, if you're working on something in commerce, you shouldn't have to become a smart contract expert or a blockchain expert. You should be able to pick up something like Move, and you don't have to worry as much about these safety issues because the compiler and the tool chain will guide you to writing the safe code. And it might be hard to get your code to compile at first, but you get actionable error messages that tell you what's going wrong. And once your code is done, you don't have to worry about the horrors of random serial dynamic behaviors or some of these other things that just make it really, really hard to write safe code in the EVM and on other platforms. So it's a two-pronged strategy, and we're working on both at the same time. But definitely the early interest from the Solana folks and from the crypto community has been promising, and definitely in Sui, like when we see product builders start to pick it up, and that when they hear they don't have to hire a smart contract developer, they get very happy. So I think that will work well too.
Definitely a huge benefit, and I know smart contract development is a huge bottleneck to development as well. So if you're able to help obviate that need, then I think that's a huge accelerant to a lot of developers.
Absolutely, yeah. The current development cycles are so long, and when you inject audits into the mix, it's just not a recipe for iterating quickly and using the process we all use to build products in the startup world. When you have this month-long audits process that is going to be at the end of your development cycle and then might not even catch anything. These auditors book by the hour. They don't say we're going to audit your project. They'll be like, you can have some hours of my time on this day and I'll audit what I can, and the rest, good luck. At least we've heard that from some folks. So we need to get beyond that. I'm not saying Move removes the need for audits, but you can get rid of a lot of the stuff to drastically reduce the scope of the audit. And then you can also use tools like the move prover so that you specify and verify all the properties you care about. And the auditor's job is basically reduced to like make sure the specifications make sense and push the button to run the tool.
Definitely hear a lot of horror stories from the Solidity and EVM Ethereum worlds of waiting a year, 6 months for a very simple review. So I think any way you can help reduce that time and the bottleneck, I think is great. And like you mentioned, probably not removing the need for audits, but potentially reducing the overall scope of that. I wanted to shift topics to better understand SWI, which is the primary L1 that Mysten is developing and pushing forward. I understand that right now it's in an incentivized testnet phase, if that's correct. And my understanding is that it's a fork of the Libra DM chain, along with I understand there's a couple other forks like Aptos and ZeroL of the Libra chain. And I was wondering if you could share a bit more about the unique aspects of SWI compared to some of the other Libra forked L1s, and also some of the so L1s outside of SWI and the like. What is distinguishing about kind of these Libra forks, and within these Libra forks, what distinguishes them, say, between SWI and Aptos and ZeroL and things like that?
Yeah, so SWI is actually not a Libra fork. There are two Libra forks that I know of. There's OL, which came out in fall of last year, as you mentioned, and then
Okay.
there's Aptos, who's in testnet now, and I think are launching a testnet later. And like, let me tell you why, because we certainly could have launched a Libra fork. We started around September of last year. Of course, all the co-founders worked on DM Libra. Like we designed many key aspects of the system. We really know how it works. We know what it does well and what it doesn't do well. And basically, like the decision we had, which we thought very carefully about, we were looking at Libra and like how, it's okay, it's this sort of designed to be this permission system and it's designed to be the settlement layer, but like, can you change it to be more of an open blockchain, something? And it was also very much designed to be a single node architecture. We're like, okay, it's a settlement layer for hundreds of VAS. It's not going to have to do too many transactions per second or hold too much storage. And so these problems can be mitigated, but at the same time, we're starting to do our biz dev and talking to game developers, and we were just looking at their level of ambition for what they wanted to do with chains. And, we were sort of adding up the different TPS numbers that folks were asking for from all the different partners we talked to. And it's sort of like, well, if we get just these three partners, they're going to max out what we think DM can easily do in a big hurry. And we don't want that, because we want to, like, the whole point is we want to bring as many people on board, and we don't want to have what happens in these other chains where you start off with low fees while traffic is low, and then you max out the system and fees go up, and now it's just as bad as everywhere else. Really, like, we want a system with Web 2 style horizontal scalability. What I want is a validator can be one machine, or it can be a cluster of commodity machines. And if I need more throughput, I need more storage, I can just add more machines, and I get that. And then maybe I can even do this in an elastic way, where if there's a spike of traffic, because we know transaction traffic is very spiky, we provision a couple more machines for a bit, and then we go back to normal. And so this is not at all easy to do with DM. And this is the reason why we decided to build something new that doesn't have these sequential bottlenecks that make it hard to do this sort of strategy. And so with SWI, what we did is we started from the ground up with this goal in mind of, we want a horizontally scalable system. And we came up with a new data model that's different from what was used in DM and what's used by the EVM and Solana and elsewhere. And basically, it's taking what Move is doing and just sort of baking it into the very base of the system. In SWI, things aren't based on accounts. They're based on objects. The structure of the global storage is super simple. You have an object. An object has a unique owner, which could be an address or another object. And then objects have these unique IDs. And then transactions, they don't operate on accounts. They say, hey, I'm going to take this object or this set of objects as input, and I'm going to mutate them, transfer them, whatever I'm going to do. And a transaction can only touch those objects. It can't touch other things that it hasn't mentioned. And so what this lets you do is it gives you a lot of benefits in terms of parallelizing both consensus and parallelizing execution. If you have a bunch of transactions and they're touching distinct objects, great, you can execute them in parallel. And with SWI, you can sometimes even commit them in parallel, because we have the ownership information baked into the object itself. If you're doing something like a token transfer or an NFT mint or a SWI transfer that doesn't involve multiple writers, that only involve objects that are owned by a single party, then we can use this systems primitive called Byzantine consistent broadcast that is much lower latency than full consensus, which is basically quadratic in the number of validators. And so in SWI, we have this data model. We leverage it everywhere. We leverage it to make this nice, really object-centric programming experience for the users. We leverage it to send things through full consensus when we need to, but then to skip full consensus when it's safe to do so. And we also use it to have parallel execution all the time, even when you have these shared multi-writer objects, because transactions are saying like, I'm touching this transaction's touching a shared object X, and this other one's maybe touching a shared object NFT mint. Those things are independent. We know we can execute them in parallel. So this is I could go much deeper into various parts of Sui or what's going on, but basically like it's not a DM fork. And the reason it's not is because we really wanted this property of horizontal scalability that you can get when you have explicit dependencies. Like, okay, now I can shard by the owners of, I can provision multiple machines. I can shard by the owners of the object. And then because a transaction tells me what it wants, it's easy to prefetch that information from the appropriate shards and then go and do the execution. And this can all be done inside the boundaries of a validator. It doesn't have to be a complicated system level sharding that gets exposed to users and like has higher fees. It's just a Web2 problem of, okay, provide the illusion of a user that has a single app, and then you do some fancy engineering in the background so that you can fetch things and just make things run. You know, these aren't easy problems, but you can hire folks from Facebook and Google and Amazon, and Netflix to know how to do it, versus protocol level sharding is like an open research problem that has UX consequences that I think are not possible to fully mitigate. And folks are just trying to figure out how to get to work.
Yeah, one of the properties I saw that was really impressive that is enabled by this new structure is incredibly high TPS. I think you advertised 160,000 TPS in the initial launch of Sui, the announcement of Sui. I was curious to hear from you about some of the unique use cases that aren't able to be handled by current blockchains that Sui enables in to the verticals that I think you talk about primarily on the Sui's page around gaming, which you mentioned before, as well as finance, decentralized finance.
Yeah, so I think the easiest thing to explain there is the just use cases that just fundamentally aren't cost effective with the throughput or storage costs of existing blockchains. So you know, if like you're trying to do something like micropayments, you know, folks have talked about this for a long, long time, but we actually still haven't seen the system where it's cost effective enough and low friction enough to make that work. And then in terms of gaming, like if you have a game that has tens of millions of users, which many games do, and maybe you want to airdrop assets to all of them, or you want each of them to have game items that are represented as NFTs and take multiple on-chain actions per day, then you really need the scale of a system like Sui to make that work. I think there are lots of other opportunities too in DeFi. This architecture where you can have shared objects and you can have single writer objects, and you sort of get you get more expressivity with one but more performance with the other. It lets you have these hybrid implementations of things that before like always use shared objects. Like you can or implementations of things that involve shared objects that are more parallelizable. Like you can have a DEX where each of the pools in the DEX is a separate shared object so that you can do trades independently if you're hitting different pools in the DEX. Or you can have an auction where the step of collecting the bids is fully parallelizable, but then the step of actually seeing who won requires a shared object to sort of quantify over everything. And then also from a programming experience standpoint, we will think a lot about like NFTs and making them richer. Like in other platforms, you usually have a standard that really limits what you can do, sort of caters NFT use cases to lowest common denominator, where the standard basically says like you have to specify what the URL for like the real data is, and then maybe the ability to transfer the NFT. But then this stops you from having fields with mutability. Like, you know, maybe you have an NFT that evolves over time just by mutating a field. This should be a natural thing to do, but basically you have to standardize every behavior you want in an NFT. And in Sweep, it's one way to think of it is like everything's an NFT, everything's an object. It has built in the ability to transfer it. It has built in a unique ID. So you can add whatever fields you want. You can have on-chain logic for mutating them. You can migrate whatever bits of the game you want online. That has benefits for transparency and trustlessness. Like the players of the game could see, okay, the magic of the sword isn't just going to like go to infinity, like a trust that code, or like the game developer isn't going to do that behind my back. And for folks like marketplaces, all the data they need to see the value of an item is right there on chain instead of like having to fetch it from some external source. So there's a broad variety of things we think will be possible, both in terms of both from the scalability benefits that Sui enables, but then also like the expressivity you get from having a typed representation where a lot of the stuff that has to be standardized elsewhere is just a built-in platform feature.
Got it. So yeah, a lot of these microtransactions, which even on Ethereum are just a pain to transact with, even on L2s, due to fees or other types of UX, would be a much greater possibility on Sui, is what I'm hearing. And it seems like the primary primitives that you're using are this kind of object model. Everything is effectively an object. That's a really interesting analogy you made in the sense that everything is almost an NFT. And and that allows very different properties than I guess you would typically see on other blockchains. I I was curious as you're building out the Sui ecosystem. I know that with any new L1, there's this suite of kind of primitives and initial dApps and other things that are required to actually get users to onboard onto the ecosystem. I think I saw that you guys released a reference wallet, and then maybe there's a couple third-party developers that have created their own wallets, like Ethos Wallet. I'm curious, beyond like wallets and the like, what are some of the other core components that are required to bootstrap the Sui ecosystem? How are you thinking about that, and how can builders start to plan to help build some of these primitives? So, what are some of the biggest needs there in your mind?
Yeah, absolutely. We call this class of thing ecosystem enablers, and we think of this as distinct from like end user facing apps. Like something like a Dex is like very important for a platform, but it's like not necessarily something that an average end user would use. A crypto degen is different, but of course. So we think of a broad category of things. So wallets are very important. You mentioned those. You need the DeFi primitives to bring liquidity to your chain and sort of drive the economy of it. So that's things like AMMs and DEXs. That's things like token issuance. That's things like bridges to port over liquidity from existing ecosystems. So we're investing in each of those by working with partners who have built high quality bridges elsewhere, who have built DeFi elsewhere, particularly on Solana, as you mentioned. Like you're seeing a lot of builders who have leveraged the aspects of that, and then also things like folks. There's a lot of building blocks for NFTs that you need as well. So like these are things like NFT standards or like standards for marketplaces. So we have a huge ecosystems team that's composed of a bunch of really creative and interesting folks who are connecting us with a lot of partners who are trying to build out these areas. And then in wallets as well, a lot of wallets are trying to leverage this object model to provide a much safer experience in terms of things like signing transactions. Like you don't have to sign some opaque blob that you don't know what it does. Like the data model, because you know what objects are coming in, lets the wallet provide transactions permissions. You can say, oh, this transaction wants to read this object and write this one and transfer this one. Does that sound okay? So we have a lot of partners that are very eager to like actually build a consumer safe wallet using these platform features. So basically, I think like all of these things are super important just to get activity going on the chain and make it worthwhile for actual app and product builders to get going. And we're doing a mix of partnerships and grants and just recruiting folks who are excited about Sui and what it can enable.
One layer beyond some of these initial primitives like Dex's AMMs, wallets, and the like, are some of the gaming and DeFi use cases we talked about. I know that you've started to build partnerships on the gaming side, including during the launch of the announcement of Sui as well. During GDC, I think you announced a couple of partners, and I'm curious how have crypto native gaming companies versus traditional gaming companies, how have they received Sui and working with Move and the like, and what have been some of the most surprising things you've heard from them in terms of uh, comments and feedback and things they're excited about?
Yeah, absolutely. I like the way you partition that because these things tend to be very different. I think from non-crypto native gaming companies, the most common thing we see is basically like we've seen the potential of Web3 for a long time. We've been like looking for an in. We sort of like look at all the platforms that come out and talk to people, and we just really haven't seen something that we feel like is gonna meet the needs for our scale and our expressiveness and our security. We feel like Sui is the first entrant in that space. So that's the early feedback from them. And then with them, we're just always stunned by their level of ambition and sort of like the creativity for the things that they want to do. I mean, of course, like there's things like putting assets on chain, but we have one partner who's building some on-chain anti-cheat detection where it's sort of they have a game like many games are that split across the client side and the server side, and they sort of have like I know if the client starts in this state and then there's some set of possible end states, but I don't get trusted execution of the client code because they might have jailbroken their phone or something else. And so they can have anti-cheat detection when you actually go to claim something where it's like, well, I see this isn't a possible outcome based on what I know, and then they can prevent that from happening. So like that kind of thing is very cool and very creative. And then a lot of creator monetization as well. Like, you know, this is another thing where folks have talked about it for a long time, but it's just like hard to actually make it work. Like that's another interesting and creative use cases that these folks are going with. From the more crypto native builders, I think we've heard it's sort of similar feedback in some ways, but there's a lot of problems we have to solve in terms of how do we help them port over their NFTs from existing chains, or like what are the, in addition to the scalability stuff, like what are the unique aspects of Sui, like the NFT mutability or like the safer wallets that we can enable. And so with them, it's a lot of feedback on convincing them that it's worthwhile to move or to launch their next game or next product on Sui, and just figuring out the logistics of how that could work. I think there hasn't been anything like incredibly surprising so far. I think the most surprising things will really come up when folks get deep enough into building that, you know, we've seen a couple of different games. Basically, like I think the second game made by a studio that's launching on Sui is going to be the one where it's really like, okay, you know, we did our first rodeo, we sort of matched what was done elsewhere, and you know, maybe improved a little bit, but then like we really understand the platform and have watched what other people are doing enough to really understand what's possible and to go beyond our imagination, their own imagination of what a crypto enabled game means.
Yeah, it seems like there's an ocean of possibilities to be explored, especially as more and more companies get involved and builders get involved. We have a lot of builders in our audience, and I was curious if you had any tips or recommendations on how they could get started building on Move and Sui.
Yeah, absolutely. So I'd say take a look at our docs and examples. We've worked really hard, especially on the examples part, because we know it's a new language and new platform. And like I don't know, I'm a builder myself, of course. And like the way I like to learn is like to look at examples of things I already know how to do and like try to use that to as a gateway into the sort of the platform features and the more fundamental differences. So in our repo, there's a big suite of examples around that are partitioned by category. DeFi, which is definitely of interest to your audience. There's one for NFTs, there's another for games, and there's another for sort of like basics or smart contract classics. We also have docs.sui.io, which has extensive documentation for things like the RPC interfaces and, you know, running a validator, and like tutorials for programming with Move. There's 2 books on Move that are both linked from there as well. And then there's examples.sui.io, which is sort of a Move cookbook of design patterns and like common types to see, and just sort of like helping you see like what's idiomatic Move and idiomatic Sui Move, and how do all these things work together. So I think, you know, I would just advise builders to take a look at those, like take a look at the other platforms that are coming out, and like see what intrigues you, see what's newly possible, and you know, give it a try.
Aside from starting to build and look at some of these tutorials and starting to build on some of these examples that you mentioned, do you have any asks of our audience, which I mentioned is primarily builders? And if they wanted to stay in touch with a lot of the work that you're doing, is there a good way to do so?
Yeah, absolutely. So this is a very direct shell, but that's okay. Our incentivized testnet is starting this month. We've just put out earlier this week the application form to be a validator in this wave of testnet and subsequent waves. So if there are folks in your audience who are experienced validator operators, take a look and consider submitting an application. We really want to bring on as many quality folks in the community as we can. I think that's definitely a call to action. And then also, like, we're going to be launching a series of developer competitions on top of Sui, you know, sort of like a extended Move hackathons with certain themes and categories. We would love folks to jump into those. Like, I think that would be an especially good opportunity to try out Sui, and then, you know, potentially win some prizes or win a grant. I think that would be cool. And if folks want to follow what's going on, you know, follow Mysten Labs on Twitter, jump into our Discord. Discord is very active with folks building and trying out and finding things and fixing things and asking questions. I think those are the best spots to figure out what's going on with Sui and Move and Mysten.
Awesome. Well, a lot of good call to actions for our audience. I wanted to thank you again, Sam, for coming on to the podcast. Really appreciate you taking the time and sharing more about the exciting world of Sui and Move.
It was my pleasure. Thanks so much for inviting me, Sean.